Guess the value of the limit, if it exists, by evaluating the function at the given numbers. It is suggested that you report your answers accurate to at least 6 decimal places. All right, so let's keep that in mind. And we have our function. The thing we want to pay attention to is we're going to plug in these x values to see what's happening to the function. But because we have this long division bar here, make sure we put parentheses around the numerator. It's not technically necessary around the denominator because it's not a sum or difference of terms, but if you're unsure of that sort of thing, it's not a bad idea to do. So in the calculator, it will look like e raised to the, in parentheses, 4.1x. So that way we have the entire exponent, 4.1 times x in the exponent, minus e raised to parentheses 3.7x, then close parentheses, and then divided by x. And like I said, if you want to put that in parentheses, that's fine. If you don't, it doesn't matter. So let's try this out. Clear that last function and type this in. So we have e raised to the 4.1x minus e raised to the 3.7x, close parentheses, and then divide by x. And I'm not going to use parentheses, but you can, that's fine. Now, what I want you to notice is even though this function involved an exponential with the base e, it doesn't change our process at all. All we're doing is still plugging into a function and observing what y values are, and the calculator is doing all that heavy lifting for us. It doesn't matter if the function involves sines, cosines, tangents, logarithms, exponentials, polynomials. It doesn't matter what kind of function you have. The process is still the same when you're doing these numerically. So make sure your table settings are set properly. Independent to ask, dependent to auto. Go into your table, and you can start plugging in these points of interest here. So point 2 evaluates to, what they say, 6 decimals. So 872, 822. Point 872,822. All right, and then when we plug in point 1, it is 0.590832. So 590,832. And 0.05 gives me 0.486132. 0.01 is 0.415908. 0.001 gives me 0.401563. So here, it looks like the numbers are changing quite a bit, but if you'll notice, we started at 0.8, and now we've kind of settled in that the first decimal is 0.4, and I bet the second decimal is going to be 0. And as we keep going, we'll probably see more decimals kind of lock in place. And that locking in place of decimals, that's what's telling us that we're getting closer and closer to a limit. So here we have 0.400156. And the next one is 4 zeros. So that's 0.400016. All right, now, there's no values on the left-hand side, but the limit here as we approach from the right, what that is so all these values of the x are all on the right hand side of 0. So the limit as we approach 0 from the right, and I think that's needing to be indicated there. So let's add that in. It looks like it's approaching 0.4 because it looks like these zeros are sort of kind of locking in place here and they're canceling out. So I think it's going to 0.4.